Deploying Windows 10 Enterprise virtual machines is the subject of this module. Now that Microsoft has included Hyper-V in the Windows client, we can deploy pretend computers just as easily as those server administrators can. Now, the topics we'll cover include installing Client Hyper-V, creating a virtual machine, creating a virtual network switch, and tweaking Hyper-V to squeeze the most performance possible out of our VMs. Installing Client Hyper-V is our first topic, and I should point out that this feature is only available on Pro, Enterprise, and Education editions. I guess Microsoft doesn't want us creating virtual machines at home. Also, you have to be using a 64-bit version of Windows 10. Why would we consider installing Client Hyper-V? Why not just use it on the server platform where it was originally provided by Microsoft? Well, while I doubt that Globomantix would want to configure every Windows 10 workstation in their organization to run Client Hyper-V, there are certain employees who might like it or need it. Server administrators, for example, can use their Windows 10 systems to tweak, test, and tune virtual machines that they ultimately plan to host on the server side. In addition, software testers can experiment with new programs or features in a safe sandbox without risking corruption or damage to their workaday laptops or desktops. The Globomantix design engineers might be using a marvelous program to optimize the angle of a solar collector array at any given latitude, but if that program doesn't play well with Windows 10, well, they might be able to run it in a virtual machine running Windows 7. And finally, Globomantix tech support could find it very useful to be able to boot into whatever OS and OS image any particular user might be inquiring about during a trouble call. Client Hyper-V has a reasonably large subset of the full server-side Hyper-V feature set. It supports both 32-bit and 64-bit virtual machines as guests. Remember, the host has to be a 64-bit platform. It permits migration of virtual machine storage. It supports both the older VHD virtual hard disk format as well as the newer VHDX format, which is more robust. It can use both local storage and network-based storage for those VHD and VHDX files, including, by the way, solid-state disks, which really help the performance of the guest VMs in my experience. Client Hyper-V is compatible with the Big Brother version that runs on Windows Server, so IT pros can copy virtual machines between the client and server platforms with some confidence. And here's something that even the server flavor doesn't support. Client Hyper-V allows the host system to go into sleep or hibernate mode without damage to the VMs, something that we couldn't do on earlier versions of the Windows client. Now, not all machines can run Client Hyper-V. I already mentioned the requirement for a 64-bit host CPU. That host machine must also support something called Hardware Assisted Virtualization, or HAV. Microsoft makes available a Hardware Assisted Virtualization Detection tool that you can download. Its name is the Hardware Assisted Virtualization Detection tool. The host processor also has to support Second Level Address Translation, or SLAT, and you may have heard of that. That just helps handle the translation of virtual addresses to physical addresses on the host machine. Now, whether a CPU supports SLAT or not is info that you can get from the manufacturer or perhaps from utilities that can report on processor capabilities like Core Info. There's probably a dozen of them. In addition to needing 64-bit hardware, you also have to have a 64-bit version of Windows 10, as mentioned earlier, and you're going to need at least 4 gig of RAM, but maybe more, depending on the size and number of virtual machines that you plan to host. Plus, you should have beaucoup of disk space, again, depending on how many VMs you plan to support. For example, a typical Windows 10 VM might need 25 gigabytes or so, and that's before you even load it up with applications. Well, we can install Hyper-V a variety of ways. The feature can be enabled in a deployment image, for example, via an unattend.xml answer file. We can also enable it via PowerShell using the Enable Windows Optional feature commandlet. And we can turn it on via the good old Programs and Features control panel on the Windows 10 desktop. And there's the location of Hyper-V. You have to select Turn Windows Features on or off rather than install a separate program per se. Notice that you do need to reboot after installing Client Hyper-V. Windows itself, interestingly, runs as a client after you've installed Client Hyper-V. Well, after the installation, we're going to see a new console, Hyper-V Manager, which we're going to use to create new virtual machines and virtual switches and fine-tune them for performance. We'll also get the virtual machine connection, which is kind of like a mini remote desktop tool that we can use to connect to a VM that we've already created and set up. Of course, there are some PowerShell commandlets that we can use these days. Just about everything we can do in the GUI, we can also do in PowerShell. In fact, there's some things that we can do in PowerShell that we can't do in the GUI. We'll notice a new group called Hyper-V Administrators, as well as a handful of new services that we can see in the Services Administrative tool. Now, installing Client Hyper-V does fall into the category of major surgery. It alters quite a bit of the PC's plumbing, and so it's not the worst idea in the world to back up a physical machine before you add the Client Hyper-V feature, just in case something goes awry.